There is a mistake. Anyone find the mistake yet? There's a mistake in there. Where? Don't know. Okay. Summer. -2 squared is not -4. And that is a mistake that many of you made yesterday. It's an innocent mistake. You know, you forget to put the brackets around your -2, but -2 squared is +4. It should be +4, which makes this 36. And now you guys can continue. You already solved it with 28? No, I said once you find the mistake, make the correction. Did you read the instructions? Wait, you don't have to answer that. And finish solving the equation. So now we've found the mistake. Thank you, Summer. We've made the correction. Finish solving the equation. So we got our -b, which is 2, plus or minus root of 36, which is a nice round number, and divide that by 2. Oh, we use plus in the one, we use minus in the other. Excuse me. Yeah, I'm playing catch up. So we're using the quadratic formula. Yesterday we set up these tables to help us progress. Some of you might not need them. On the 3M task today, I think I have a table for everyone. All right. Do this in as many steps as you want, but the root of 36 is 6. And then when you add 2 and 6, you get 8. I got 4. How about you guys? 4 for the first one? All right. And then 2 minus 6 divided by 2. Minus 4 divided by 2. Minus 2. So hopefully you guys practice. Maybe if this was new to you yesterday, you might got to start investing some time outside of this class to make sure you're developing the skills, okay? That's a realistic expectation for an advanced level math course. All right, there's a mistake in the second one. Can you guys find it? I'll wait a second. There is a mistake. It should be positive 40. -4 times 2 times -5. Yeah. And that so this should be not minus 24. Did I fix yours? You guys, does yours have a root sign on it?
No.
No, yeah, I fixed yours. I didn't fix my electronic copy. But yeah, it should be the root of 56. Okay. And now you guys can continue. Same old, same old. -b plus, in this case, root 56. And divide by 4. Now, root 56 isn't a perfect number, so you're going to get decimals here. Today, I'm going to show the 3u's, how we can simplify this. The 3m's, you just got to use your calculator and get the decimal. Slightly different expectations. Yeah, -4 times 2 times -5 is positive. Two common mistakes that I see every time I teach this subject a couple times a year for 16 years. Okay, do it in one step, do it in multiple steps. I'm doing it in 2 steps. I did the top, I did -4 root 56. My display calculator is awesome. It can do that in one step for me. Using your phone, not helpful, nor should we be. As per board policy, phones are often away during instructional time. I got about 0.87. And what about the next one? But don't be a sheep. If I do something wrong, let me know. I got 0.87 and negative 2.87. Now, I've been known to make mistakes, but yeah, I think that's all good. Anyone get the same thing? Or blank stairs than normal. Okay, so negative 4 plus root 56, and then divide by 4. Well, seems good. It's you guys that are wrong. Yeah, 0.7, right? All right. Good, good, good. And remember, when you're practicing at home, load up a quadratic formula solver on your computer, check your answers. All right. I wanted to extend a little bit further because you guys did a lot of these yesterday, so we should be getting kind of proficient. I wanted to give a little bit of meat for the 3M people trying something new on their assignment. This is the kind of thing we didn't do yesterday, like an application plus an equation where we have to do some manipulating. I made this question up a few years ago. Brian's a bit taller than 1 meter now. But Brian does do this. He takes balls to his school and just roofs them for fun. And then I have to pay for new ones. Brian is trying to roof a tennis ball. And the roof is 10 meters high. And so he can throw a ball with a speed of 15 meters per second, a vertical speed. And we're going to find how long it takes for Bryden's ball to reach 10 meters high. Now, where this equation comes from, we'll learn tomorrow. But for now, you guys can trust me that that's an equation that models what we're doing. Have you physics people done acceleration due to gravity yet? Oh, do you guys remember what acceleration due to gravity is? Do you know the number? 9.8 or around like 10 meters per second. So half of that 10 meters per second is negative 5. That's where that comes from. And then the initial speed is 15. That's where that comes from. And Bryden's 1 meter tall. That's where that comes from. Anyway, I'll show you guys how to build those tomorrow. Is this ready to use, or do we have to do a little bit of massaging before we can use the formula? Jillian, were you answering that? What do we have to do? Yes, so we need to put everything on one side. Now, what's that? Oh, what did I say? Oh, okay, yeah. Clearly, next school day. Now, you guys have some choice. You can move the 10 over to the right, and then that's only one thing you have to do. But then you have a few more negatives to work with. Or you can move all this other stuff to the left, and then there's more positives. I'm not your dad. I'm not going to boss you around and tell you what to do. I'm going to just move the 10 over because it's just one thing. I'm going to do this, move over the 10. So what are we left with? 0. I'm going to show a couple steps here. 5t squared plus 15t plus 1. And then we'll get a nice, we haven't used deep red yet. Let's do that. So we're adding 1, and then we're subtracting the 10. And so the equation we're solving is this, minus 5t squared plus 15t minus 9. So a is minus 5. I can print. A is minus 5. B is 15. C is minus 9. And I'll have you guys carry it out. Yep.
If we were to move 15 and 1 over to the other side, wouldn't they become negative? Wouldn't there be 1 negative?
If you moved in the end, so if you moved, that's an excellent question. So I'm just going to show you what would happen. I'll do it on the left over here. So let's say you moved all this stuff to the left. What would happen? So you'd have your 10, and then you'd have positive 5t squared, right? And then 15t would be minus 15t, and then you're right, it would be minus 1. But then you're going to be adding 10, right? And at the end of the day, you have 5t squared minus 15t, and negative 1 plus 10 is positive 9. It's a little bit less negatives to work with. They're both going to give the same answer. Excellent question. I'm going to commit to what I had before. 2 times a, 2 times -5 is -10. B squared, 15 squared, -4 times -5 times -9. That's a lot of negatives, but that's okay. 15 squared is 225. And negative, 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 that'll be subtracting, and then 20 times 9, I think it's 180. So it should be 45. Because it's negative times negative times negative, so we'll be subtracting. I think that's good. All right, I'll let you guys finish it off. Now, our equation is in terms of t and not x, so I'll just use t1. It's negative 15 plus root 45. Yep. Divided by negative 10. Negative 15 minus the root of 45 divided by 10. So if the physics people, if you guys have done 1D kinematics, you might have been using the quadratic formula to do stuff just like this. Maybe? I will do 2 steps like I normally do. I'll do the top, negative 15 plus root 45. I got negative 8.29 divide by negative 10. That just moves the decimal. So about 0.829, this is seconds. And then minus 15 minus root 45 minus 21 point, we'll call that 71 divided by, well, that should be negative 10. You bunch of sheep. It's negative 10. You guys can let me know if I make a mistake. I'm just kidding. I like you guys. You're not sheep. And call it about 2.17. I think. You guys let me know if I did something wrong. But I have a visual here for us to check. I actually graphed out the equation and put a line where it's equal to 10. And do these match up? About 0.8 seems to fit. And a little bit over 2, what do we say? 2.17. About 2.2 seems to fit. Would you guys agree our answers seem to fit? And one thing to point out as well, we got 2 possible times, 2 different solutions that both make sense. Because Bryden's baseball, whatever he's throwing, it goes 10 meters high on the way up, and then it hits 10 meters high on the way down. So it makes perfect sense in this question to get 2 times, 2 possible times where his ball is roof height. So we moved the needle a little bit, a bit more to chew on for the 3Ms. I've got a question like that on your on the little task I got here for you guys. So anything you guys want to chat about before we go our separate ways? All right, I'm going to get everybody what they need. And then 3M people, if you could, I'll try to tour when I can. If you're helping each other out, just try to, keep it really low whispers. Oh, sorry. All right. Do you guys like adding, subtracting rational expressions? It was okay? This is much better. Hello.
Hi.
Can I help you with something?
No, I'm just returning stuff that was taken from this room for the forest festival. Yeah.
Homework? It's the lesson we're doing together. Talk about that. All right, I think I got everybody. Yeah.
Kennedy only got one page.
Oh.
It's not a booklet.
Oh, that's why I had more than one. That's why I had extra copies. Jammed when I was doing that, so that was. All right, let me open up the document you guys have, and we'll get started. All right, I enjoy teaching this lesson. It's a new skill for you 3U people, brand new, but it's manageable. So yeah, we should have a good time. Now, you guys remember way back in grade 9 with Miss Answers, or who was your grade 9 teachers? Nobody had me. Miss Answers. You had me in grade 9, that's right. Yeah, there you go. I can remember stuff. Yeah, I taught AJ in grade 9, I taught you in grade 9, Kennedy I've had every year. But we talked about different number systems, and rational numbers were a number that could be expressed as one integer over another. So here's some examples of rational numbers. A number like 2/3 is a rational number. Yes. You don't have it? What did I give you? Nothing? I gave Animal one and one. A number like -4/7 is a rational number. Did you guys know whole numbers like 5 are rational numbers? How can you write 5 as one integer over another? Jillian. 5/1. That's right. So integers are rational numbers. Even like 0 is a rational number because you can write that as 0 over anything, really. 117. But some numbers cannot be expressed as a ratio of two integers. So these numbers are called irrational numbers. So Kennedy, Richard, love that you guys are collaborating. Just need to dial it down a little bit. It's just the nature of having two courses in the same room. Okay? Thanks for cooperation. Some examples of irrational numbers. A number like pi is an irrational number. You guys know pi, like 3.14159, blah, blah, blah. That's as far as I can go. That's an irrational number. Other irrational numbers are of this form, where it's the root of a number like 2. The square root of 2 cannot be expressed as one number over another. In fact, when you do root 2 in a calculator, it gives you a decimal that never has no repeating pattern. Root 3, root 5, etc., etc., etc. But note, I didn't include the root of 4, or things like the root of 9, the root of 64. They are not irrational numbers. Can you guys have a think? Why is something like root 9 or root 64 not an irrational number? Maybe somebody that hasn't helped out yet today. Because you can square root them. Yeah, the root of 9 is equal to 3. That's a rational number. The root of 64 is equal to 8. That's a rational number. It's because they're perfect squares. They are perfect squares. But if you have a number that isn't a perfect square, its square root will be an irrational number, like root 2, like root 3, like root 5. So what you guys are learning today, you guys are learning how to work with what we call these guys, radicals. So today we're gonna really just focus on multiplying them together and simplifying. It's really, in my opinion, what you need for your grade 12 courses. And so I'm going to just focus on this today. We're going to do a little investigation on multiplying radicals. I want you guys to grab your calculators. We're going to do a little calculator work here and see if we can develop a little rule or a pattern for multiplying radicals, a little rule, if you will. So we all have a display calculator, so you can just literally type in the root of 4 times the root of 4. As you see it there, and it should spit out a nice number for you. It should be 4, right? That's how square roots work. I mean, some of you guys might have even just used mental math for that one. The root of 4 is 2. The root of 4 is 2, and it gives you 4. But you can just punch it in as you see it. In the second column, we just have one square root where we have the multiplication underneath. 4 times 4 is 16, and the root of 16, also 4. Ooh, spooky, Halloween. Weird coincidence, or maybe not, right? So can you guys keep going? Some of these are going to give you decimal values, which is okay. Some of these, the numbers are too big for mental math. So can you guys go down the line? If you sit with somebody, maybe one of you do column A, one of you do column B. I'll do both because I'm the teacher, so I got to do more work than you guys. The first one? Let me see how you. Oh, I know what you did.
I just fully typed it.
Yeah, so make sure you put in brackets the 4 times 4, because then it will tell it to do the it'll do the multiplication first. Yeah, glad you brought that up. Yeah. Because if you don't do brackets, your calculator will do the root of 36 first, and then multiply that by 36, which is not what you want. So if you display calculator people, make sure to use the brackets. Did I teach you nothing in grade 9 about order of operations? That's my fault. All right, I got 36 for this one. 36 times 36. Can I do the mental math? No, I can't. 1,296, of course. How could I forget? But I think when you square root that, you also get 36, right? Yeah, interesting. Okay. Now, those are perfect square numbers. How about the root of 5? Okay. Root of 5 times root of 5 is just 5, right? That's how square roots work. Well, look at that. The root of 5 times 5 underneath the root. 5 times 5 is 25. And we get 5. The same thing. Really interesting thing is happening. But you might be like, well, maybe Mr. Smith, this only works for when we're multiplying by like the same thing. Well, let's see if it works for two different radicals. Root 12 times root 9. It'll be a decimal value. That's okay. And then do 12 times 9 first, and then root it and see what you get. Root 12 times root 9, which is 3. About 10.39. Oh, 9 times 12 is 108. Square root that. I got the same thing. I mean, it's possible we're now into a little bit of overkill territory. But it appears there's a pattern here. Let's just finish it off for completeness sake. Root 7 times root 6 separately is about 6.48. And then the root of 42, I'm going to guess it's about 6.48. Yep. And then root 13 times root 21. I think you guys get the point. But it doesn't matter whether you root first or multiply first, you get the same result. 16 point, you guys get 16.52 on the last one? I see nods. Okay, let me finish it off for completeness sake. Root 273, which will be the same thing. All right, this is the big idea. This idea is central for everything we do today, and it's what you guys need to take out of today. When you're multiplying two radicals together, it appears that this gives you the exact same result as if you just multiplied them first and then square rooted everything. You guys get that down? That's the big idea. Would you guys agree that it appears this is true? It looks like this is true. And it is true. And it's something we can use to our advantage. I'm going to show you guys how today. It's going to be fun. All right. A little bit of terminology. The reason we're doing this today is for you guys taking 3U, like we are covering bases to get you to 4U, to get you to calculus, to get you to university math. That's why you're in 3U, to keep those doors open. A lot of applications will require you guys to use exact values. So often that means leaving things in terms of radicals and not just decimal answers. It's why we're working with those skills today. So a bit of terminologies first. So when you have a radical and the entire root of something is called a radical, but the thing underneath it, the number you're rooting, is called the radicand. Radicand. And I'll probably never use that word again ever in my life, except the next time I teach this course. But it's called the radicand. Today you learned. It's good dinner time conversation. And we kind of had a talk about this earlier, but if you think about values of the radicand that will give irrational numbers, we talked about this on the front, right? The root of 9 isn't an irrational number. It's equal to 3 because it's a perfect square. Same with root 64. It's a perfect square. So do you guys, did I take this out for your note? Do you guys have this? Okay, good. Making me nervous for a second there. So what values of the radicand will give rational numbers? Numbers that are not perfect squares. Okay. Now, you can have two kinds of radicals. The first type is called an entire radical, and I'm just going to list some examples here. An entire radical is just a radical. There's a root sign and a number. So it's like root 7, root 19, root 34, pick your favorite number, etc., etc. Those are called entire radicals. A mixed radical is a radical that is being multiplied by a coefficient. So a mixed radical would be something like 2 times root 7. You guys know, like a mixed number with fractions was like 2.5 or 2 3/4. A mixed radical just has a coefficient. So it's 2 times root 7 or 3 times root 19 or 4 times root 34, something like that. Yes. Mm-hmm. Okay. Do you want to speak to her privately or in front of everybody? How about privately? Private. Don't mind us, just like us. All right, so sometimes we can simplify entire radicals. This is the first new skill for you guys, so hang on to your butts. Now, I thought it would be helpful if I listed the perfect square numbers up to 12 for you guys here, so we have them there. But check this out, this is really interesting. So the root of 50, just like with fractions we can put in lowest terms, we can take radicals with really massive numbers and reduce them to something simpler. And the key is using perfect squares. Can you guys have a look? What perfect square number goes into 50? 25, right? So follow along with me. I'm gonna like deconstruct 50. I'm gonna write 50 as 25 times 2, just like that. 25 times 2. Underneath the square root. I'll show you why. Remember the rule we just saw where you can multiply under a square root and then root it, or you can separate them? This is the same as the root of 25 times the root of 2. They mean the same thing. And what's the root of 25? It's exactly 5. The root of 50 is equivalent to 5 times root 2. This is a simplified radical. The numbers are smaller, easier to work with. It is to our advantage to do this. Can you guys humor me? On your calculators, what's the root of 50? 7.0, 7.07, something. Blah, 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 blah. Okay. Can you guys do 5 times the root of 2 on your calculators? So it's not close to the same thing. It is the same thing, right, guys? They are equivalent in every way, but this is simplified. The numbers are smaller, easier to work with, to our advantage. All right, let's do another one. We're going to simplify a mixed radical. Can you find a perfect square number that goes into 27? You got one, Jillian? Nine. No, so check this out, guys. We can write 27 as 9 times 3. Why would we do that? Because 9 is a perfect square. And we can rewrite this as 2 times the root of 9 times the root of 3, using that cool rule we saw in the front. The root of 9 is just 3. So we have 2, and you can do this any way you want. I might just add in some brackets. Root of 9 is equal to 3. Showing a lot of steps here. And 2 times 3 is equal to 6. Very cool. And you guys can check it for yourself. 2 times the root of 27 is exactly equal to 6 times the root of 3, which is really neat. And what's the point of this? The point is to make things simpler. Reduce the numbers, make them smaller. We've got 2 in the books. Anything you guys want to chat about so far? Let's really dial in. This is like a fresh unit. I know some of you guys struggle with the rational expressions. This is a new skill, but it's a manageable skill. You just got to dial in. We're going to do root of 180 2 ways. Now, I'm going to choose a specific way to do this first. Would you guys agree that 9 goes into 180? 9 goes into 180 20 times, right? So I'm going to rewrite this as the root of 9 times 20. So that's the root of 9 times the root of 20. And this is equal to 3 root 20. Excuse me. But you know what? Root of 20, I think we can go further. You guys see a perfect square number that goes into 20? 2 isn't a perfect square number, though. 5 is not a perfect square number. Well, 1. 4, yeah, 4. So we can actually keep going. I can write the root of 20 as the root of 4 times 5. And I can write that as the root of 4 times the root of 5. I'm showing a ton of steps here. The root of 4 is equal to 2. And 3 times 2 is 6. We get 6 times the root of 5. So sometimes, maybe if you're trying to simplify a radical, maybe you got to do it twice. Because the first time you did it, then things get quite simplified enough. And this happens all the time. Like if you guys are simplifying, let's say the fraction 10 over 20, maybe you saw right away, oh, I can divide those both by 2, and you get 5 over 10. But then you realize, silly me, 5 over 10 is equivalent to 1 over 2. Sometimes that happens in real life. Rose and Peyton, you with me here? You're not convincing me. You guys are chatting all period. Dial in. So in the same way, sometimes you might simplify a radical, and you might need a couple of steps. It's more practical to try and simplify it the first time all the way. Yeah, 9 goes into 180, but can you guys find an even bigger perfect square number that goes into 180? There's an even bigger one. It's in that little table there. See if you guys can find it. Just start dividing if you're not sure. Just do 180 divided by 16, divided by 25, divided by 36. So you find one. Anybody find it yet? 180 divided by 16. Nope. 180 divided by 25. Nope. 180 divided by 36 equal to 5, right? So 180, we could have done this a lot quicker if we had just written 180 as 36 times 5. Because the root of 36 is exactly 6. And we would have got there a bit sooner. Is it wrong to use multiple steps? No, it just takes multiple steps. Now, can I give you guys, let's just be honest here. I think after this point, I think most of you guys could see, okay, Mr. Smith, I'm going to square root 36 and get 6 root 5. I think I can go right from there to there. And if you can do that, that's really good. Feel free to. I at the very least want to see you break up the multiplication, okay? Does that make sense? Okay, but yeah, you guys, root 36 is 6. You can save at least one step. All right, anything you guys want to chat about? That's 4 goes in the books. I feel like more would be a bit of overkill, perhaps. All right. Now let's tie in yesterday's stuff. So yesterday, we solved some quadratic equations. We found some zeros using the quadratic formula. Now I've done the work here. So if I said yesterday to you guys, hey, find the zeros of this quadratic function, using the quadratic formula, you'd get this. This can be simplified using our new tool. Can you guys find a perfect square number that goes into 48? Once you find it, you can just say it out loud. Not a perfect square number. Perfect square numbers are here. What'd you say? 4 is 1, but there's a bigger one. 16. Yeah, you can divide 48 by 16. So follow along, children, as we simplify our exact roots. So we're going to write 48 as 16 times 3 divided by 2. And now here, to manage my space, I am going to just do minus 16 plus or minus 4 root 3, because the root of 16 is 4. I think that's a reasonable step to skip. Now we can go one step further. You guys notice 6, 4, and 2, everything can be divided by what in this question? 6, 4, 2. Let's divide everything by 2. Divide every single thing by 2. And I might just write divide by 2 in the brackets here, just to not make my thing all clunky. And you guys can use the mental math for this. Minus 6 divided by 2 is minus 3. Plus or minus. And 4 divided by 2 is 2. And of course, in the bottom, 2 divided by 2 is 1. So you might be thinking, Mr. Smith, that doesn't look a lot more simpler than the original one. It is. The numbers are reduced. It's a little bit easier to work with. And It is going to be useful for some applications that later on, maybe in 4U. You guys just have to trust that professional knows what he's talking about. Can you guys try the next one? 72. What's the biggest? It's worth investing a tiny bit of time to find the biggest number that goes in. If you think you found the biggest, try a couple more and see if you can find the biggest number that goes into that. See if you guys can take it over. I'm going to do a quick tour with the 3Ms and see if I can help it all. So remember, negative times negative, you can add 56. Okay, and then you can keep going. Okay? Okay, you start. Okay? Berkeley doing okay?
I think so.
Yeah, looks like you're churning it through it. That's good. Which one you guys on? Good. Yeah, you can divide by negative 4. Yeah. There, you gotta be careful with negatives, yeah. Well, you should bring up the solver and check the other answers too. You can go to our newsfeed and use the one that I linked yesterday. I did link that one. All right, what's the biggest number that goes into 72? Perfect square. 36. Good job, Peyton. Okay. So let's see if we can simplify this a bit. So we'll write 72 as 36 times 2, all divided by 6. And then the root of 36 is 6. Aha, so this is going to look so much nicer because I can divide everything by 6. And we get 1 plus or minus root 2. If like me personally, I would rather type 1 plus root 2 into my calculator than all this garbage. So save some time. So if you guys happen to dig back into your practice from yesterday and you have a question saying find the exact roots, when you guys look up answers in the answer key, you will see the simplified form. So that is something to be mindful of moving forward. All right, things are going well. Anything you guys want to chat about? All right, we just got one more thing that you should be equipped to do. And that's multiplying radicals or even multiplying mixed radicals together. And this should go by pretty quick, actually. You guys should be able to do A using our skill from the front. So root 3 times root 6. I'm going to show every single step for this one. It's my space underneath. I think I can do this. So follow along. What we do is we multiply the radicands together. So we saw on the front side that we can do root 3 times root 6. It's the same as doing 3 times 6 in square rooting. And I think most of you guys could probably just go to root 18. That would be reasonable for you guys just to say, okay, I know what 3 times 6 is 18, Mr. Smith. But can you guys simplify that? Is there a perfect, you look up root 18, you're not going to see root 18 in your answer key because it's not simplified. 6 goes in 18, it's not a perfect square though. 9 goes in. So we simplify. 18 is 9 times 2, and the root of 9, I'm going to show this extra step. 3 root 2. So you multiply the radicands together, and then you might have to simplify. We get 3 root 2. So I might actually add root after root 18 here. Simplify. Let's do another. So here we're multiplying 2 mixed radicals together. It's actually not that hard to do. I outlined the steps for you guys. Just multiply the coefficients together. So we multiply 2 times 3. So 2 root 3 times 3 root 5. Multiply 2 times 3. That gives you 6. And then multiply what's underneath the square root signs. 3 times 5. Are you guys okay if I just do 6 root 15? I just multiplied the numbers together, 3 and 5. This would be reasonable for you guys just doing practice. If you need to write out 3 times 5, continue. Now it's worth having a think. 15, can we simplify that any further? Are there any perfect square numbers that go into 15? And our perfect square numbers are 1, 4, 9, 16. Well, there's only 3 that work. 1 doesn't really help us, and 4 and 9 don't go into 15. So this is actually done. Sometimes you don't have to take things any further. Yes? Sure. Can you guys try the last one? And then I think our timing today was perfect because we're going to have about 25 minutes just to practice this new skill. Five root 2 times 4 root 8. That's just really messy looking. I wonder if it'll simplify to something really nice. Same. Bum, bum, bum. 5 times 4 is 20. 2 times 8 is 16. Now, when you guys see root 16, you shouldn't be thinking what perfect square number goes into 16. 16 is a perfect square, so you actually can just square root it. The root of 16 is 4. And 20 times 4 is actually just 80. Isn't that kind of crazy? 5 root 2 times 4 root 8 is just equal to 80. And you can try that on your calculator. I'm 99% sure that it'll work. That's all I got to teach you for today. That's what I want you guys to be able to do with radicals. Simplify them, be able to state quadratic formula roots in the simplest way possible, and multiply radicals if we need it. Anything you guys want to chat about? Okay, just thought I'd ask. So 3U people, I have curated, that's a fancy word for stolen, some questions from the 3U textbook and just pasted them in here. That's why they're a bit out of order. I just cherry picked ones that I thought would be good after our lesson. And I've got numerical answers on here too.